Okay, before we get into the lesson on squares and square roots, let's review a few things. So when we talk about the square of a number or a perfect square, that means that we have a number to the second power. So that would be like 5 to the second power, which is 25, is a square number or a squared number. And then a square root is the opposite of that. So in this example we just looked at, 5 times 5 is what 5 squared means. That's how I get 25. So all operations have opposites. So if I added 10 to something and then I changed my mind, I wanted to undo that, I would subtract 10. Or if I multiplied by 2, to undo or do the opposite, I would divide by 2. So to undo this squaring, that's what the square root does. So the square root of 25 is 5 because 5 times 5 is how I got to 25 in the first place. So when we're doing the square root, it's what number times itself gives you this number. So in this case, what number times itself is 25? 5. And another reminder for order of operations, and specifically the common mistakes that we're still making are that multiplying and dividing come at the same time. So these are interchangeable. Sometimes you're going to multiply first and sometimes you're going to divide first. Add and subtract come at the same time also, so these could be interchangeable. Sometimes you add first, sometimes you subtract first. So as you read across the page left to right, when you're doing multiplying and dividing, whatever you see first, you do first. And then once you're done with all the multiplying and dividing, you can move on to the adding and subtracting. And then same thing, you go across left to right, and whatever you see first, you do first. Alright, so find the squares of each number. 5 squared means 5 times 5, and that is 25. We just did that one. 3 squared, that means 3 times 3. 3 times 3 is 9. 7 squared, that means 7 times 7, and that is 49. And 1 squared means 1 times 1, and 1 times 1 is 1. Okay, so here we get into the newer stuff for this lesson, is when we're going to find the square root. So the square root is 16. I need to think what number times itself gives me 16. And I know that 4 times 4 is 16. So the square root of 16 must be 4. And for 100, I know that 10 times 10 is 100. So then the square root of 100 must be 10. Number 7, the square root of 1. So again, we're thinking what number times itself is 1. And I know that 1 times 1 is 1. Just like we did up here, 1 times 1 is 1. So the square root of 1 is 1. And then we get into these fractions. The square root with a fraction. So there's 2 different ways we could potentially solve these. First, we're going to make a note off to the side over here that if we have the square root, if we're looking at that example, 50 over 2, that is the same thing as square root of 50 over square root of 2. We don't have a problem like this, but this works the same way. If I had square root of 12, I could split that up into square root of 4 times square root of 3. So you can divide square roots separate or as a whole. So here's them divided separate, here's them put together as one square root. And when you multiply 2 square roots together, it turns into one bigger square root. Okay, it doesn't work for adding and subtracting, but it does work for multiplying and dividing. But for number 8, if we look at what we did over here, that actually doesn't help us because I can't take the square root of 50 and I can't take the square root of 2. Those are not perfect squares. So we think back to the perfect squares list. We want perfect squares. So square root of 1 is 1. I'm just going to go down. 3 times 3 is 9, so square root of 9 is 3. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. I'm just going to continue down this list. And it really is helpful if we can have memorized up through at least 12. It's going to make things a lot easier. Okay, so we're going to use this list a lot. So in number 8, I can't take the square root of 50 or the square root of 2. Because nothing times itself will give me 50, and nothing times itself will give me 2. Here are my list of perfect squares. So all these means that I can find the exact answer, like square root of 4 is 2 because 2 times 2 is 4, or 3 times 3 is 9. So those are perfect squares. So then instead of separating this into two different square roots of number 8, I need to simplify this expression. So a fraction really means division. So this really says the square root of 50 divided by 2. Well, I can do 50 divided by 2. 50 divided by 2 is 25. And I still haven't used the square root sign yet, so I just brought the square root sign down. And now if I look over here to my list, I know the square root of 25 is exactly 5. A little bit different, though, is this number 9. On number 9, if I were to separate these out into two square roots, I recognize that 81 is on my list of perfect squares, and so is 36 is on my list of perfect squares. So I can actually take the square root of both 81 and 36. So in this case, it helps me to separate these out. If I try dividing 81 divided by 36, that's going to be a lot harder to do. It's going to get me a decimal value. But the square root of 81 is 9, and the square root of 36, what times what is 36, is 6. So then this ends up being 9 over 6. You can reduce that, 9 over 6, sorry. You can reduce that as well, or we're just practicing the square roots right now, so it is fine to leave it like this. So again, when you have these fractions, sometimes, like number 8, you want to divide first and then see if you can take the square root. Other problems, like number 9, it won't help you to divide first. Instead, we can take the square root of each number. Okay, 10 and 11, we're using order of operations within a square root. So that square root's kind of acting like a grouping symbol. Within that grouping symbol, we're going to follow order of operations. And we have to divide before we can subtract. So we would have to leave 27 minus, and then 22 divided by 2 is 11. And then 27 minus 11 is 16. And the square root of 16, remember we're thinking what number times itself is 16, and 4 times 4 is 16. Once you take that square root, the square root sign goes away. Number 11, following order of operations, we have to do exponents first. So I have 3 plus, and then 2 to the third power. Remember that means 2 times 2 times 2. And that's going to be 8. And then we still have a minus 2 at the end. Then we're going to add, subtract. Those come together. Whatever we see first, we do first. So I'm going to add first 3 plus 8 is 11. And then 11 minus 2 is 9. And then I can take the square root of 9. I'm thinking what times itself is 9, and 3 times 3 is 9. So square root of 9 is 3. And again, I've taken that square root now, so I don't need the square root sign anymore. It's just 3. And then we're going to learn how to estimate. So square root of 30, I can't actually do. No number times itself will give me 30. We're going to start by just finding the two nearest whole numbers. So what we're going to do is we're going to go over to this list of perfect squares. And once you start having these memorized, it'll make this a little bit easier. So I'm going to go over to this list of perfect squares, and I'm going to see where would square root of 30 fall. So on my square root side here, so I'm looking at the square root side of this list, and I'm looking for where would square root of 30 fall. Well, square root of 30 would fall right in between here. 30 goes right in between 25 and 36. It goes right in between here. So if square root of 30 is between here, then if I go all the way across, its answer then must be between 5 and 6. So this would be between 5 and 6. And if you did check it on a calculator, we would see that we get the decimal 5 point some value. We're going to repeat with square root of 15. So again, I'm going to find on the square root side, because it's a square root of 15. 15 falls right in here. Between 9 and 16 is where 15 would fall. So then I follow that across, and that means it must be between 3 and 4. if we needed to estimate more specifically, I can see, well, 15 is really close to 16 and not so close to 9. So it might be 3 point, something close to 4, 3.8, 3.9, something around there. And then our last one, square root of 70. 70 would fall right in between here, which means its answer falls right in between 8 and 9.